Standard 6.1, Simplifying Expressions with Integer Exponents Using Properties of Exponents. So for each example I'm going to do here, I'm going to first give you the different properties that are relevant to that example and explain why those properties actually hold true. It's hard sometimes for us to memorize the properties, but if you know where they're coming from, you can reproduce them going back to the meaning of exponents. So for our first problem here, example 1, we're going to be using the product property. And the product property says the following. The product property says that if you have a base to an exponent times the same base to an exponent, that product is that base to the sum of the exponents. So for example, if we have 2 to the third times 2 to the fourth, that becomes 2 to the 3 plus 4, which is 2 to the 7th. And where the property comes from is the expansion of 2 to the third and 2 to the fourth. 2 to the third is 2 times 2 times 2. 2 to the fourth is 2 times 2 times 2 times 2. And if we condense this, we get back to 2 to the 7th. Our property allows us to take the shortcut of just adding our exponents 3 and 4. All right, so let's take a look here at example 1. Example 1, we are multiplying two expressions together. Now, since the only operation that we have within this problem is multiplication, we can actually rearrange the terms because the order that we multiply in doesn't matter. So it makes the most sense to multiply your numbers together first, negative 8 times negative 7, and we'll do the f's together. F to the 6 times f squared, and we'll do the g's together, so g times g to the 5th, and then we have the h. And now let's multiply each piece separately. So our first product is 56. F to the 6 times f squared is an application of our product property here. So we add our exponents. Again, if you're not sure, expand. This is 6 f's, this is 2 f's. Altogether you have 8 f's. So this becomes f to the 8th. Similarly here, this is g to the 1st, that 1 is implied. So we add our exponents g to the 6th, and then we still have our friend h hanging out at the end. So this is as simplified as we can get. All right, let's take a look at example 2. Now, example 2 makes use of a few other properties. So we need to know the quotient to a power property. Let's start with that one. So the quotient to a power property says, suppose we have a quotient, two things that are being divided, and that's being raised to a power. We are allowed to distribute that power into our quotient. So that becomes a to the m over b to the m. Exponents are distributive under division and multiplication, but never under addition or subtraction. All right, so again, if you have a hard time memorizing these properties, here's where the quotient to a power property comes from. Let's look at a more specific example. Let's say we had 2 fifths to the third power. If we were to expand this using our notion of exponents, this becomes 2 fifths times 2 fifths times 2 fifths. And if we were to condense it, we have 3 2's that we're multiplying together, or 2 to the third, and 3 5's, which is 5 to the third. The quotient to a power property says, hey, we can just distribute. So you can memorize the property, but you can see where it's actually coming from. So that's one property that we're using. And the second property that we're using in this example is power to a power. So the power to a power property says that if we have some base raised to a power, and that expression is raised to another power, we are allowed to multiply those powers together. So for example, I'm running out of space here, but that's okay. For example, if we were to look at 2 to the third to the fourth, our shortcut, our property, says we can multiply our exponents 3 and 4 together and get 2 to the 12th. Now if we're confused and we don't understand the property, we can expand. 2 to the 3rd to the 4th really means we have 2 to the 3rd 4 times. That's 2 to the 3rd to the 4th power. And each 2 to the 3rd gives us 3 2's. So we have 3 2's and 3 more 2's, so on and so forth, for a total of 12 2's if we condensed it back together. Shortcut, multiply the exponents. So if we go back to our example, how do we apply these properties here? Well, notice that we have parentheses and we have this exponent outside of our parentheses. Since we have this division symbol, this division bar indicating that we have a quotient, we are allowed to distribute the power to each part of the quotient. So we can take, and notice there's a negative 24 and a t to the 6th there. So each of them get the exponent of 5. Negative 24 to the 5th, t to the 6th to the 5th, and then on the bottom here, we have 8 to the 5th and t to the 3rd to the 5th. Now, if we were to use our power to a power property, we have negative 24 to the 5th still. T to the 6th to the 5th becomes t to the 30, as we learned in that property, over 8 to the 5th, and then t to the 15th. Now we can simplify some more using another property. We also have what's called our quotient property. And our quotient property says if we have a quotient, two things being divided, b to the m over b to the n, we can subtract our exponents, b to the m minus n. So for example, if you have 2 to the 4th over 2 to the 3rd, you can subtract your exponents and get 2 to the 1st. Now if you were to expand this, you could see 2 to the 4th is 4 2's on top, 2 to the 3rd is 3 2's on the bottom, and if you started canceling 2's out, you'd be left with 1 2 on the top, or 2 to the 1st. So applying that property here, we have t to the 30 over t to the 15th. We can subtract our exponents and get t to the 15th. And now we can use our calculators and evaluate negative 24 to the 5th divided by 8 to the 5th, and we can get negative 243. So that is our final answer. Now we could have looked at this a little bit differently. We could have done what's inside the parentheses first and then distributed. So I'll do that in a different color here, green. If we take a look at our original problem, negative 24 t to the 6th over 8 t to the 3rd to the 5th. Suppose we did what's inside the parentheses first. You can divide negative 24 and 8 and get negative 3. And using our quotient property, we subtract our exponents. This becomes t to the 3rd, and this is all raised to the 5th power. Now we can use a different property called our product to a power property. I know it's getting squished in here, so I apologize. But product to a power says, suppose we have a product like a times b to a power m. We are allowed to distribute that power into our product, a to the m times b to the m. And again, if you have a hard time, let's see if I can move this example. I don't know if I'm going to be able to, but oh, yes I can. Okay, so what we could do is look at an example that can help us understand where this property is coming from. So for example, if we have x times y to the 4th, this becomes xy times xy times xy times xy. And if we rearrange and condense, this becomes x to the 4th and y to the 4th. And so you can see our shortcut says, hey, we're just allowed to distribute that power and get x to the 4th. Whoop, some funny things are happening here. Okay, y to the 4th. So let's use that property here in our green example. We've already divided. Now we can distribute this power in. So we get negative 3 to the 5th times t to the 3rd to the 5th. And if we multiply this out, this becomes negative 243. And a power raised to a power, we saw earlier, we multiply our products together. So we get the same answer regardless of which way we choose to go. Please continue to view Standard 6.01 Part 2 to see some more examples. These include ones with negative exponents.